Good morning, students. I am Suman. Today we'll discuss the same chapter, magnetic effect of electric current of class 10, and the topic is the magnetic field due to current carrying conductor and state experiments. On previous day, we have been seen that the magnetic field and magnetic field line around a bar magnet. Today, we will see the magnetic field due to current carrying conductor. What is magnetic field due to current carrying conductor? Suppose that in any conductor, if the current flow through any conductor, the magnetic field produced around it. So the magnetic field produced around a current carrying conductor, and this magnetic field is due to flow of charge or flow of the electron. So here this statement has been first observed by the Ørsted Christian Hans Christian Ørsted, a Swedish scientist who observed when a current flow through a conductor, there is a magnetic field around it, and experimentally he proved that he took a closed path. He took a closed path. This is a closed path. Closed path. This is the closed path, and this is the switch, and this is the sources of current. This is sources of current, and the electricity flow through in this direction. This is the closed path, and he put a magnetic. He put a magnetic compass. Magnetic compass. And as he switch on, there is a deflection. This is the north-south direction of the magnetic compass. And as the switch on, he saw there is a deflection in this compass. And this deflection is in this direction. This is north and south. So because we know that when we put a magnetic compass, it shows always the north-south direction. So as the current flow through this closed path, and the magnetic compass when we placed near the current carrying conductor, this is a thick copper rod, this is thick insulated copper rod, and as we switch on here, so current flow through this circuit, and there is a deflection in the magnetic compass. The next experiment, he reversed the direction of the current. So as he reversed the direction of currents, then what's happened here? This is a switch, and the sources of current again. Now here we change the direction of the current, and this is again we take a thick copper rod, and this copper rod is insulated. This is the insulated thick copper rod, and we will put again a magnetic compass near this thick copper rod. As we switch on, the current flow through this circuits means is in this direction. Now we'll put here a magnetic compass, Initially, there is no deflection, and the magnetic compass shows the north-south direction. This is north and this is south direction. So as we switch on, there is a deflection in the magnetic compass which is away from this closed path. As we switch on, the deflection of this needle of the magnetic compass is away from this closed path. So in this experiment we observed here, as the current flow through a closed path or any conductor, there is a magnetic field around it, and this magnetic field is due to the current. It means when the charge flow in any conductors. So the magnetic field of the conductor is depend upon the strength. This magnetic field, strength of magnetic field depend on strength of current flowing through the circuit. This means as the strength of current will increase, the magnetic field around the conductor or around any conductor will increase at the same rate. And as we switch off, the conductor lost their magnetism and the needle again comes back on its original position. So the state shows the current. When a current flow through the circuit, there is a magnetic field produced around it, and this magnetic field due to a current, and that's why it is the magnetic field due to current carrying conductor. So the conclusion is the magnetic field produced in a conductor when a current flow through it, and the direction of magnetic field is different due to the direction of the electric current. In this diagram A, and this is diagram B, as you are watching, in the diagram A, the current is flow in upward direction, and the direction of the magnetic field is this direction. And in the diagram B, the direction of the current is downward direction. So the direction of magnetic field is away, means this direction. So the direction of the magnetic field line around a current carrying conductor is depend on the direction of the current flow through the circuit. This is the conclusion of the Ørsted experiment. Next topic we'll see on the next day. Till then, thank you.